Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, and in this session we'll be showing you the use of Parallel to Curve in our HSS module. What I'd like to do in this part over here is to work on these surfaces around the part itself, parallel to this curve over here, to this edge over here of those surfaces. So I'll simply go into my operation and choose my HSS option, and I'll use the option of parallel to curves within my list of options. In my geometry area, I'll choose my drive surfaces, and my drive surfaces will be the first selected faces as shown over here, around the part over here. Those are the surfaces I'd like to work on. Now, my edge curve will be the edge as shown over here, and this edge must touch the edge of the surfaces that we chose to work on, our drive surfaces. Next, I'll choose my tool, and in this case I'll be using a 6mm ball end mill, and in my levels I'll be using my retract in Z as I've done before. And now when I get to my toolpath parameters, I'll be using a maximum step over of every 2 millimeters. Now let me do my save and calculate now and see what the results of this is. Now if I take a look at my simulation, you'll note that my toolpath is going around the part parallel to the curve. But now we'll note a little bit of a problem. Note the very edge of my toolpath. My tool in this particular case, since my toolpath is going up across the edge itself, which is the center of my tool, I'll be actually gouging these walls over here, which is not exactly desirable. So what I'll do is as follows. I'll go into my option of gouge check. Now I'll activate my first gouge 1, and in this particular case, I just want to make sure my tool tip or my tool shaft working only on the drive surfaces. Now unmark the check surfaces, that if it sees a gouge in those areas between this, what will happen is it will retract going according to the tool axis, in other words in my Z axis as well. Now in my second gouge area, I would like to also enable that, and this time I like to have my check surfaces only, that if the tool hits my check surface, and my check surface in this particular case will be, as you can see over here, around the entire part, which if it will crash into those areas, or if it sees itself going to crash into the areas, I'll choose a different strategy. This time I will say leave out gouging points, and what I'll do is I'll say trim my toolpath after the last collision. In other words, all those trim points, all those points will be left out of my toolpath itself. Now besides the gouge checks, I like to go back into my link for a moment and have changed my first entry and my last exit, and I would like to use my lead in and my lead out. Now in my lead in, I'd like to have this as a vertical tangent, but in my lead out I would not like to have it the same as lead in. Instead, I'll have this as a tangential arc, and in this particular case I'll also use this option of height. When I use the option of height, as you can see in my diagram over here, I will give it, say, a height of 10 millimeters, and what will actually happen that the tool will actually go out, plus it'll also go up to that height. I've changed it here to 10 millimeters. I could even make it at 1 millimeter. And now when I do save and calculate, and we take a look at our toolpath simulation, you'll see that the toolpaths will go around the part, and you can also see that my lead in is coming down from the top, curving in, and my lead out is going out with a curve as well. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.